So we talked about sets and we talked about combining sets. One more thing that we often need to do when we are looking at a set is to figure out how big it is, how many elements are in it. For sets, the size is called cardinality. The reason for that is for sets we want to be able to talk about size of both finite sets and infinite sets. And the way we write it is the same notation as you would do for the absolute value, the two vertical bars. So for example, if you have a set with A elements, like this set 1, 2, 3, it has 3 elements in it, so its cardinality is 3. If you have an empty set, it has nothing in it, so it has 0 elements in it. Its cardinality would be 0. So if you want to think about it in a type-checking way, think about it this way. If you want to figure out, evaluate what the cardinality of a set is, what do you need to get as an input? Well, you need to get as an input a set, and something that says that what you want to do with it is to figure out its cardinality. And what is your output? It's a number. So if you're getting a set ABC, you get out a number 3. And if you're trying to write cardinality of a set, all you do is you take the name of the set and put vertical bars on both sides of it. So finite sets are things like 1, 2, 3, A, B, C, D. All the numbers between -10 and +10, all the integers between -10 and +10. Some sets are infinite, natural numbers, integers, rationals, reals. A very common set that you encounter in computer science is a set of all finite length binary, in particular strings. So it's like a string 0, 0, string 0, 0, 1, and so on and so forth. Because even though every string is finite, there are infinitely many of them, this would be an infinite cardinality set. So now let's use this notion of cardinality to solve the enrollment puzzle from last time. So this was the puzzle. There are 160 students taking COMP1000 this semester, and there are 105 students taking COMP1002. And you want to find out how many students are enrolled in both of them if you know that the total number of enrollments in those two courses is 200. So here is what this problem is asking you to do if you translate it into sets. So you have two sets, students taking COMP1000 and students taking COMP1002. And you're told the size of each of those sets, its cardinalities, and you're also told the cardinality of the union of the two sets. Students that are either taking 1000 or 1002 or both. And what you want to find out is the cardinality of their intersection, students that are taking both. So here's how we can do it. So let A be students in COMP1000 and B set of students in COMP1002. The cardinality of the set A is 160, cardinality of set B is 105. Cardinality of A union B is 200. Now let's think about those sets and those numbers. So if we just try to add up number of students in 1000 and number of students in 1002, we get a number that's going to be more than 200. And that's because we would count some students, namely students that are in both, twice. One time we would count them as students in 1000, and second time we would count them as students in 1002. So now it tells you how to solve the problem. We just need to find out how many students we counted twice, and that will be exactly the students that are in both. And this gives us a formula that the cardinality of an intersection of two sets, A and B, is equal to sum of cardinalities of both of set A and a set B minus the cardinality of their union. So number of double counted students is sum of number of students in both minus what is the actual total number of students in between of those two classes. And this doesn't just apply to the enrollment puzzle. This is a general phenomenon. Whenever you have for two sets, you could find out the cardinality of their union if you know the cardinality of their intersection and their cardinalities, and vice versa. If you know how many are in both, if you know how many are in either and you know how many are in each, you could figure out how many are in both. So if your sets are such that there is nobody in both of them, this formula tells you right away that the total number would be the number of in the first plus the number in the second, just because the number of the ones that are double counted would be 0. So this applies not just to 2 sets, it applies to 3 sets, 4 sets, and so on. The formula does get a little bit more complicated. So let's look at this diagram and figure it out. Suppose we now have 3 classes, for example, 1000, 1001, and 1002. Some students are taking all 3, some are taking 2 of them, some are taking only 1. How do we find out how many students are enrolled in any of those 3 first-year courses? Well, we sum up the number of students in each of those courses, and some students we counted twice, some students we counted 3 times. Okay, so let's subtract all the students that are counted twice and 3 times. We subtract all the students that are both 1000, 1001, 1001, 1002, and 1000, 1002. But now we subtracted out all the students that are in all 3 of them, because we counted it 3 times and we subtracted it 3 times. So now we need to add that number back in. And this is what gives you this formula. And you could go and figure out the formula for any number of sets. Remember that the general rule is you sum at one level, then you subtract at the next level, then you add again, then you subtract again, and you go until you get something that's intersection of everything.